There is a structural innovation that can cool a home by 15 degrees Fahrenheit in the height of summer without a single moving part, a single fan, or even a single watt of electricity being consumed. While the modern construction industry relies on mechanical HVAC systems, with a coefficient of performance that degrades every season, this technology turns the very walls of a building into a cooling system. It is a system that utilizes the density of air and the ideal gas law to create a continuous silent flow of ventilation that clears toxins, prevents mold, and reclaims your financial independence from the power grid. Yet despite being the most cost-effective cooling solution in human history, this technology has been sidelined by a building industry that prioritizes airtight, plastic-wrapped boxes over structures that actually live and breathe. To understand why this technology is a threat to the modern energy status quo, you have to understand the crisis it was designed to solve. The adoption of the solar chimney was never a matter of architectural preference. It was a necessity. The origin of this technology begins on the arid, blistering plateaus of ancient Persia, specifically in cities like Yazd. 3,000 years ago, architects faced a biological necessity: how to keep a city habitable when the ambient temperature regularly exceeds 113 degrees Celsius. They didn't have the luxury of electricity or chemical refrigerants. What they had was an intimate mathematical understanding of the density of air. They developed the Badgeir, a vertical masonry shaft that utilized the thermal lag of high-mass stone. These weren't just decorative towers, they were the world's first solar thermal engines. By utilizing the pressure differential between the shaded courtyards and the sun-baked tower tops, they created a constant thermal siphon. In many cases, these towers were paired with connats, which are underground water channels. The tower would pull air across the water, utilizing evaporative cooling to drop the temperature of the air before it ever entered the living space. For centuries, this was the global standard for high-performance cooling. By the 19th century, as the British Empire expanded into regions like India and Africa, they encountered these systems and integrated them into colonial hospitals and barracks. The British Medical Journal documented that wards equipped with these thermal stacks had significantly lower mortality rates during cholera and influenza outbreaks. The reason wasn't medicine, it was physics. The stacks provided a constant atmospheric flush, removing pathogens and moisture that thrive in stagnant air. The reason a solar chimney outperforms a mechanical fan is not about horsepower. It is about the physics of the stack effect and the Bernoulli principle. To understand the engineering of a building that breathes, you have to follow the air. At its core, a solar chimney is a vertical shaft designed to maximize solar gain. It consists of a high-efficiency absorber plate, usually a dark-colored metal or masonry surface, positioned behind a layer of high-transmittance glazing. As solar radiation passes through the glass, it hits the absorber plate and is converted into long-wave thermal energy. According to the ideal gas law, as the temperature of the air inside that shaft increases, its density decreases. The air becomes lighter than the surrounding atmosphere. These energized molecules begin to rise rapidly toward the exhaust at the top of the chimney. This upward movement creates a zone of negative pressure at the base of the chimney. Because nature abhors a vacuum, the building is forced to inhale. It pulls fresh, cooler air from the lowest, most shaded part of the building, usually a north-facing intake or an underground earth tube, and drags it through the living spaces. Because the system is powered by solar radiation, the pumping speed of the chimney is in direct proportion to the heat load on the building. On a 100-degree Fahrenheit afternoon, when an AC unit is struggling and drawing maximum current, the delta T, the temperature difference between the collector and the ambient air, is at its peak. The chimney is at its most powerful, moving thousands of cubic feet of air per hour without moving a single mechanical part. But what happens in the winter? This is where the dual-mode engineering comes in. A properly designed solar chimney includes a bypass damper. In the winter, you close the exterior exhaust and open an interior return vent. The rising hot air is no longer dumped outside. It is recirculated back into the building's thermal mass. This effectively turns your cooling tower into a massive solar air heater. The performance of this atmospheric engine is dictated by two primary variables: the height of the stack and the temperature difference. The taller the shaft, the greater the pressure differential and the higher the velocity of the air. This is the engine displacement of your home. The performance of these systems isn't anecdotal. It is backed by decades of bioclimatic research. In 1995, researchers at the University of Arizona conducted an extensive audit of a residential solar chimney in the Sonoran Desert. They found that the system maintained an indoor temperature of 75 degrees Celsius, while the outside air was a blistering 106 degrees Celsius. That is a 17 degree Fahrenheit reduction using nothing but the weight of the atmosphere and the heat of the sun. But the real evidence is in the air changes per hour. The Environmental Protection Agency estimates that indoor air is often 2 to 5 times more polluted than outdoor air. In a modern airtight home with a standard HVAC system, the air is mostly recirculated, providing less than 0.5 air changes per hour of fresh air. This leads to the buildup of volatile organic compounds, CO2 and moisture. A solar chimney, on the other hand, provides between 8 and 12 air changes per hour of 100% fresh filtered air. This constant atmospheric flush prevents the sick building syndrome that plagues modern residential construction. It is the mechanical equivalent of leaving every window in your house open without the security risk or the loss of thermal control. On carbon and sustainability, the comparison is not remotely close. To manufacture, install, and operate a standard 3-ton central AC system over its 15-year lifespan carries an embodied carbon debt of approximately 25 tons of CO2. A solar chimney constructed from high-mass masonry, recycled aluminum and glass has a carbon payback period of less than 6 months. Once the structure is built, the operating cost is zero. It is a carbon-negative asset that increases the value of the property while decreasing the operational overhead. The impact these systems have on your energy independence is massive. A study by the University of Nottingham showed that buildings utilizing solar chimneys could reduce their total cooling energy consumption by up to 75%. In a world of rising energy costs and grid instability, this is a level of security that a mechanical machine simply cannot provide. So why wasn't it adopted? The answer lies in the way we finance and regulate comfort. The modern building industry is built on a foundation of subcontracting and standardization. It is easier for a developer to build a cheap, thin-walled, uninsulated box and then pay an HVAC contractor $5,000 to add a mechanical heating system. It's a plug-and-play solution that requires no specialized architectural knowledge and no integration into the building's footprint. Then there is the energy dependence trap. The utility companies and the manufacturers of mechanical cooling units have zero incentive to promote a technology that never breaks, never needs a filter change, and never sends a monthly bill. The modern framework that locks solar chimneys out of the American landscape is the International Residential Code. While the code doesn't explicitly ban solar chimneys, it is written entirely around ASHRAE 62.2 standards, which prioritize mechanical inputs. Because a solar chimney is passive, meaning its performance varies based on the intensity of the sun, it falls into a regulatory void. It doesn't have a UL listing or a factory-certified Energy Star rating because it isn't a product. It's an architectural feature. Most local building inspectors will insist on a mechanical backup system anyway, effectively doubling the cost of the build and forcing the homeowner to buy a machine they don't need. It is a de facto ban through bureaucracy. We are told that active systems, the ones with compressors and refrigerants, are modern and passive systems like chimneys are primitive. But in reality, the machine is the primitive solution. It relies on brute force, high energy, and complex moving parts that are designed to fail. The chimney is the sophisticated solution. It relies on an elegant, permanent understanding of the laws of the universe. It is a succession of failure, where you are forced to buy a machine designed to break, to fix a house that was designed to fail in the first place. If you want to integrate an atmospheric engine into your own home, here's what that looks like in practice. For an existing home, the most efficient path is a wall-hanging solar chimney. This is an insulated box attached to a south-facing wall. To build one, you need an absorber plate coated in a selective surface paint, a material that absorbs 95% of solar radiation but has low emittance, preventing the heat from radiating back out through the glass. You then cover this with low emissivity glass to trap the heat inside the stack. For a 500 square foot space, you need a collector area of approximately 20 square feet. The cost for a DIY build sits between $300 and $500 using UV-stabilized polycarbonate and high-temperature silicone. You cut two 6-inch vents into your wall, one at the floor and one at the ceiling, and let the physics take over. For new construction, the pro move is to design the structure as a dedicated thermal exhaust engine. Unlike a retrofit, a new build allows you to calculate the precise neutral pressure plane of the building to maximize the stack effect. The strategy involves integrated vertical shafts, ideally 20 to 33 feet in height, built into the south-facing thermal mass of the home. These shafts must be lined with a spectrally selective absorber plate and shielded by high transmittance, low iron glazing to prevent thermal radiation. By placing the air intake at the lowest, most shaded point of the structure, the chimney creates a continuous pressure differential. This forces the house to inhale geothermally cooled air at the ground floor, while simultaneously exhaling the hot, buoyant air through the roof-level vents. This creates a 0-watt, high-volume air exchange that can provide between 8 and 12 fresh air changes per hour, effectively replacing the need for a mechanical compressor. If you really want to achieve radical autonomy, you pair your solar chimney with an earth tube. You bury a 100-foot run of 6-inch PVC or clay pipe 6 feet underground, where the temperature remains a constant 54 degrees year-round. The solar chimney provides the suction that pulls fresh air through that pipe. By the time the air reaches your living room, it has been geothermally cooled to 70 degrees. This is a no-watt air conditioner that works even during a total grid collapse. The maintenance is the final piece of the puzzle. Because there are no moving parts, no refrigerants, and no motors, the system is a forever machine. An annual check of the intake filters to ensure high-velocity flow, and a cleaning of the glazing to ensure maximum solar transmittance is the only requirement. Unlike an AC unit that requires a $200 service call every year, a solar chimney is a permanent structural organ of the house. The solar chimney is a 3,000-year-old answer to a 21st-century problem. If you allow physics to do its work, it will turn your home into a silent, self-regulating engine of air, without the need for the grid, the utility company, or the succession of failure that defines modern housing. A lot of this knowledge was nearly lost not because it stopped working, but because the industry decided that simplicity wasn't profitable enough. Reclaiming the lost art of self-sufficiency and high-performance building is the simplest way to ensure this kind of knowledge keeps being found. While the solar chimney uses the sun to move air, the same thermal mass logic can be applied to a wall that turns solar energy into heat. The Trombe wall, a genius design that can reduce heating bills by 70%. Building a solar chimney is not just a construction project, it is an act of defiance against a modern building industry that forces you into airtight plastic-wrapped boxes designed to fail. If you want to integrate this atmospheric engine into your home, you have two primary paths depending on whether you are retrofitting an existing structure or starting a new build. For an existing home, the most efficient implementation is a wall-hanging solar chimney, which is essentially an insulated box attached to a south-facing wall. To construct this, you need a high-efficiency absorber plate, typically a dark-colored metal or masonry surface, coated in a selective surface paint that absorbs 95% of solar radiation while maintaining low emittance to prevent heat from radiating back out. This plate is positioned behind a layer of high transmittance, low emissivity glass or UV-stabilized polycarbonate to trap thermal energy inside the stack. For a 500 square foot space, you should aim for a collector area of approximately 20 square feet, which can be built for a DIY cost of between $300 and $500 using high-temperature silicone for sealing. The final step for a retrofit is cutting two 6-inch vents into your wall, one at the floor level and one at the ceiling, allowing the stack effect to take over, as rising hot air in the chimney creates negative pressure that pulls cooler air through your living space. For those engaged in new construction, the pro move is to design the building as a dedicated thermal exhaust engine from the ground up. This approach allows you to calculate the precise neutral pressure plane of the building to maximize the siphon effect. The strategy involves integrating vertical shafts, ideally 20 to 33 feet in height, directly into the south-facing thermal mass of the home. These integrated shafts must be lined with a spectrally selective absorber plate and shielded by high transmittance, low iron glazing to prevent thermal radiation from escaping. By placing the air intake at the lowest, most shaded point of the structure, the chimney creates a continuous pressure differential that forces the house to inhale fresh air at the ground floor, while exhaling buoyant hot air through roof-level vents. This configuration creates a 0-watt high-volume air exchange, providing 8 to 12 fresh air changes per hour, effectively replacing the need for a mechanical compressor. To achieve what is described as radical autonomy, you can pair your solar chimney with an earth tube. This involves burying a 100-foot run of 6-inch PVC or clay pipe, roughly 6 feet underground, where the temperature remains a constant 54 degrees year-round. The solar chimney provides the necessary suction to pull fresh air through this underground pipe, cooling it geothermally to approximately 70 degrees per hour by the time it reaches your living room. This setup functions as a no-watt air conditioner that remains operational even during a total grid collapse. Because this system has no moving parts, refrigerants, or motors, it is considered a forever machine. Maintenance is minimal, requiring only an annual check of the intake filters to ensure high-velocity flow, and a cleaning of the glazing to maintain maximum solar transmittance. Unlike a standard AC unit that requires expensive annual service calls, the solar chimney acts as a permanent structural organ of the house, reclaiming your independence from the energy status quo. To pair a solar chimney with an earth tube for radical energy autonomy, you use the chimney as a thermal engine to create the suction necessary to pull air through an underground cooling system. Here is how you implement this system based on the sources. You must bury a 100-foot run of 6-inch pipe, typically PVC or clay, approximately 6 feet underground. At this depth, the earth maintains a constant temperature of about 54 degrees year-round, regardless of the surface weather. The intake of your home's ventilation system is connected to this underground pipe. The solar chimney is positioned at the opposite end of the airflow path, usually at the highest point of the structure. As the sun heats the solar chimney's absorber plate, the air inside becomes less dense and rises rapidly, creating a zone of negative pressure at the base of the chimney. Because nature abhors a vacuum, this negative pressure forces the building to inhale air specifically through the earth tube. As fresh outdoor air is pulled through the 100-foot buried pipe, it gives up its heat to the surrounding 54-degree soil through geothermal exchange. By the time the air reaches your living space, it has been cooled to approximately 70 degrees. This pairing creates a no-watt air conditioner that requires no electricity, has no moving parts, and continues to function perfectly even during a total grid collapse. Unlike standard mechanical systems, this setup provides a constant atmospheric flush, delivering 100% fresh filtered air, while significantly reducing or eliminating traditional cooling costs. The interesting and very powerful part of this is that a properly designed solar chimney can be used for heating in the winter through what is known as dual-mode engineering. By incorporating a bypass damper into the design, you can switch the system's function from cooling to heating as the seasons change. Here is how the heating process works. In the winter, you close the exterior exhaust at the top of the chimney and open an interior return vent. Instead of the rising hot air being dumped outside, as it is during the summer, the heated air is recirculated back into the building's thermal mass. This configuration effectively transforms the structure from a cooling tower into a massive solar air heater. While the solar chimney primarily uses the sun to move air for ventilation and cooling, the sources also mention that similar thermal mass logic can be applied to a tromba wall, which is specifically designed to turn solar energy into heat and can reduce heating bills by as much as 70%. Because a solar chimney has no moving parts, motors, or refrigerants, it is considered a forever machine, with very minimal maintenance requirements. The only regular maintenance tasks necessary to keep the system functioning at its peak are annual filter checks. You should perform an annual check of the intake filters to ensure they are clear, which maintains the high-velocity airflow required for effective cooling. Cleaning the glazing. The glazing, glass or polycarbonate, must be cleaned to ensure maximum solar transmittance so the absorber plate can collect as much thermal energy as possible. Unlike a standard mechanical AC unit, which typically requires a $200 annual service call, a solar chimney functions as a permanent structural part of the home and does not require professional mechanical servicing.